So in the previous video, we basically just looked at the idea of graphing a line in the y equals mx plus b form, where m represents the slope or the steepness of your line, and whatever you are adding to that x term, whatever you're adding to that x term, that is your y-intercept for your line. So in this video, we're going to give you one more level of control over your lines, because you might notice that y equals 1x plus 2 or something like that. Let's say this is the line that we want to graph. By the way, we can clearly see that the slope of this line is 1 because going between any two clear points. Let's say that we want to go from 0 and 2 to 1 and 3. If we want to go from this first point to the second point, we would just go up by 1 and to the right by 1. So we really just have a rise over run of 1 over 1. Sorry, 1 over 1. So every time we go up by 1, to stay on the graph, we would then need to go to the right by 1, and so on, right? We go up by 1 to the right by 1, up by 1 to the right by 1, up by 1 to the right by 1. So that's the slope of this graph. And of course, we don't really need to say y equals 1 times x plus 2, because 1 times x, more simply, is just x. So here we go. We have this blue line, y equals x plus 2. Now again, as I promised, we're going to have a little bit more control over this line, because for this particular line, if you zoom out, you might notice that it literally goes forever, right? We can see our x-axis now has a scale of up to 10,000, 10,000, 20,000, 30,000, and so on. We can make the scale larger and larger and larger, and we see numbers that are so huge that we actually need to do scientific notation, which you'll learn about in science and math class eventually. But we can make the scale as large as we want, and we see that the line doesn't go away. The line literally goes forever. It goes for infinity. It doesn't stop. But let's say you only want a part of this line, and that's where this control will come into play. So let's say you only want to graph a certain chunk or a certain segment of this line. You can do that. You can control how much of this line is drawn with these two curly brackets here. So here I have a set of curly brackets. This opens the curly bracket here on the left, and this one closes the set on the right. And what we can type inside these curly brackets is inequalities. So let's say I only want to graph this particular line for x values that are, let's say I only want to graph this line for x values that are smaller than 3. So I want to cut this line off at an x value or at this particular coordinate where x is equal to 3. All I have to do is just type in x is less than 3. If I do that, lo and behold, this particular line, it gets cut off, right? It doesn't go forever up and to the right, right? It eventually stops. It stops at an x value of 3. So if you introduce these curly brackets with a little inequality, what that tells the program is that you only want to allow x values that are less than 3. Here is an x value that is less than 3. It happens to have a corresponding y value of 4. Here is an x value of 0, so that should be in the set. It has a corresponding y value of 2. Here we have an x value of negative 2. It just so happens to have a corresponding y value of 0. And all of these x values that are less than 3 can be graphed. But where the graph should be at 5 and 7, where x equals 5 and y equals 7, we should have a point here, but we don't, because we cut off x values that were that large, right? We cut off an x value of 5. We don't allow that to be graphed because this inequality tells us, nope, we can only accept x values that are less than 3. Here, this point should be at x equals 4 and y equals 6. It doesn't show up because x equals 4, well, that's actually larger than 3, and so the program knows not to allow that point. The program can only graph points that have an x value of less than 3. So that's how you can incorporate another element of control into here. Now, let's say that you also notice that as you zoom out, okay, it seems to be cut off on the right, but if we keep zooming out, it keeps on going down and to the left forever. Let's say we want to cut that off at a certain point too. We can absolutely do that. We can add another layer of control here. So let's say you want to cut your graph off right here, right where it crosses the x-axis. It's called the x-intercept. So let's say you don't want to allow any x values that are less than -2. So you want to cut off all of these x values here. If you want to do that, all you need to do is introduce another inequality. It's called a compound inequality, where x also has to be larger than -2. So here, this part of the inequality says we can only allow x values that are larger than -2. So this seems to satisfy that, right? It allows -1, right? It allows this x value of -1, this point with an x value of -1 is allowed to appear on our graph because that is larger than -2. This x value, this point with an x value of 1, it's allowed to show up on our graph because that's larger than -2. And this particular point that would be on the graph, it's at an x value of 4, and you might say, hey, that's larger than -2, but it is not less than 3. So we kind of have this compound inequality which shows us that x, we will only allow points with x values that occur in between -2 on the left-hand side and +3 on the right-hand side. And here we have what's called a line segment. You can change the boundaries of this if you like. You can allow x values as small as -3 if you like. You can see how that changes the graph. You can allow x values as small as -5 if you like, and you can see how that changes the graph. You can allow x values as large as -10 if you like, and we can see how that changes the graph. You have complete control over how much of this line you would like to be graphed, right? You can even change the rightward boundary as well, right? You can say, I only want to allow x values as large as 2, or as large as 1, or as large as -1, right? So you have a sense of control over how much of this line that you can graph, right? So really, I think that's all I want to do in this video, and in the next video, what I'm going to show you is how you can graph multiple lines and apply multiple restrictions to each of those lines to create a picture. And I'll see you then.